Good afternoon, everyone. My name is Stephen Liu. I'm a VP of Product Management from Wiwynn. So today, I would like to talk to you about Wiwynn's common building block architecture and our technology that we are investing in right now. And so this is the agenda. First, I would like to introduce Wiwynn because we are a pretty new company. And next will be our product for common building block and the technologies. And please stop me if you have any questions. OK, so Wiwynn, as I mentioned, is a new company. We just established in 2012. Right now, it's 7 years next month. And our business model, we are focusing on cloud business customers. So we provide the IT gears and the rack integration solution to cloud service provider. What we mean cloud service provider is in a broader sense that using the internet technologies and to provide a service. So not very specific to provide the hosting service. OK, so this is our mission. OK, and our strategy would maximize the customer value. So what is the value to our customers? So it's our formula. We provide the best enable customer to run their performance optimized solution at a lower total cost of ownership. So we are very focused on the customer set, and we are very focused on how we execute to meet the customer requirements. And this is our result for our focus and our execution. OK, so then we'll go to the topic that I would really like to talk to you, our building block architecture and the technologies. OK, so the good thing we have is that we have so many different rack infrastructures that provide the technology for the customer, for the industry to maximize the performance and tune the system to enable the best workloads. Best performance of workloads. But in the meantime, we are also facing challenges to certify all those infrastructures. So we have EIA 19-inch, traditional one. We have the Open Rack, and it's a 12 version and the 48 version. And there are Project Olympus from Microsoft, and there's Open 19. It's good to have so many technology to satisfy the customers, but also a challenge for suppliers like us. And also, we have diverse product line. So like we have in the industry, there's a compute optimized. And also for edge or front server. And there's different accelerator or storage. We have GPU acceleration. We have SSD, hard drive, JBOF, everything. And also have traditional multiple server and also the storage system. Actually, if you analyze more product, this is part of it. There's more comprehensive product. So how we supply and support the customers with so many diverse demands to execute to our strategy to maximize customer value. The way we did is to have the common building block architecture. Is first, the advantage for customer to deploy and ramp the system very fast, and also enable the new technology into the infrastructure in a faster version. So we change the technology or the component that only meaningful to the customer's environment. So we have designed on the software, the management, and the RSD, and also the integration on the chassis thermal solution. And then there's a board design. So the motherboard, and of course, firmware is very important on the motherboard. And also there's lots of like a power distribution board, the PCI switchboard, SAS expander. So this is a component that we designed to be modularized, so we can mix and match for different form factor, different rack to satisfy their industry and customer needs. Okay, so to further break it down, like we have motherboard for different technology, Intel, AMD, and ARM, and also the management module like a TPM or their servers. There's various form factor of the management module, but we have the similar or same connection. So from the software or the hardware is interchangeable. And also switchboard, power conversion board, and the firmware. So BIOS BMC, there's a AMI BIOS BMC and Open BMC. So in our design, we modularize the software, so it's easier for us to support different requirements. And of course, the firmware of the PCI switch or SAS SATA expander board. Then the chassis, there's, as I mentioned, there are different rack. Actually, the form factor is different, so the chassis is different. So, so we can have all these key ingredients interchangeable in most cases. Okay, so next is few of the examples that we in our product. So we show you have a feeling how we do it. Okay. First is the Mount Olympus Family. So this is a contribution from Microsoft. So there are 3 additional members in this family besides the original one. The first is the Open19 1U server, and our code name SV6100 G3. So later we will have a more visual presentation for you to understand what is it. And the next member is the EIA 19-inch 4U GPU server. It also is a family of Project Olympus. And the third member, the new member is a 21-inch OCP GPU server. Okay. And the next is the Tiago Past family. So there are additional 2 families besides the original one. The first is the we call it generic market version of the Tiago Past. And the second is the 1U 2-node EIA 90-inch. It has a power supply integrated together. So different customers, if they choose to have traditional EIA 90-inch infrastructure, they can still benefit from the OCP project that everyone invests in. And next is it's a POC project. It's we call it data center ready control module. It's DCSCM. What is it? It's it integrates the BMC, integrate the fan power supply control, and also the root of trust. It's basic TPM or servers, and also the boot drive and the flash. So if you work, then you have different technology, different system, but the management is the same. So you can change different technology, the generation to generation, and still use the same management module. And for more detail, Siamak Tavalai from Microsoft, he will have a presentation at 2:30 tomorrow. So if you are interested, please join CMA session and give feedback and comments so we can improve together. Okay, so this is the original Olympus, and you can see the I/O is in the front, in the front facing the core I/O, and the new family is Open19 1U server. What we do is we rotate the orientation of motherboard 180 degrees to the rear, and in the front we support 4 3.5-inch or 2.5-inch drive. Okay. So it's a new member, and the leverage is the motherboard and the TPM. So the major components there. So we have a adapter board, a new chassis, and convert it to Open 19-inch. So it takes just a few iteration and very fast. You don't need to develop years for a new product to satisfy the Open 19 customers. Okay. Next, this just mentioned this second family of the Olympus. It's a 4U GPU server, integrate the a GPU card. Actually, you can have different accelerator card. So it's as long as it's a PCI form factor. So the FPGA card or the ASIC card is make it a PCI form factor. You can support it, and the motherboard is the Project Olympus motherboard, and our innovation is that we have two fan run. So we direct the fresh air from the core I/O directly to the GPU. So the GPU will not suffering from the preheat of the CPU or memory. So first, it will improve the system reliability, and next, it's a longer product life cycle. Okay, so the leverage here is that, the Olympus motherboard and the switchboard actually from another family of product. So it's as I mentioned, there's a 19-inch, a 21-inch version of it. So the 21-inch OCP and the 19-inch version, they share the same motherboard, same switchboard. So we have different power solutions for these two brothers, and it reduces the efforts of the industry to support different requirements. Okay, and this is the Tiago Past family, and this is the original Tiago Past, and we have customers that require hard plug drive, two hard plug drive. So, and also some customer request dedicated management port, dedicated management BMC management port. So this is the customer requirement. So we modify the design from the original family and add a new member to the family. So the leverage is the board, TPMs, and some design of the new design of chassis, and add a hard drive board. Okay, and next is the one U2 node is an EIA 90-inch server. So the leverage here that there's customers, they require more memory. So we add 4 memory to each server. So there's a respin of the motherboard, but we keep the key layout, the processor, the memory, the high-speed I/O the same. So just take one spin, then we have a new product, stable product. So this is the also the leverage of the design to the new family. Okay, so I will turn to the new technology that we are investing on. Before I go, enter the market, is there this topic any questions? Okay, all right. So next is the technology that we're investing. There's power 48 volts is because the processor, everything, processor, memory, more memory, higher power processor, or co-processor, accelerator. So the system getting more and more power. So to support the power, the delivery of the power to the system require different solutions. So 48 volts is a new, we consider it's a new technology direction. So we have invest on it. So this is the first generation. It support 2.4K kilowatts. So the module design, and in the meantime, there's telco operator. They have minus 48 volt requirement. So we also have the module. And the latest one is we focus on the power efficiency. What is that? Our first generation, we found is the efficiency is not in a high load, the efficiency is not, we can improve. So our new technology, we have the a new idea, and our engineer will have a workshop later to share you how we optimize the efficiency of each load. So it's further improve the efficiency. Okay, and next is the cooling. We also it's the same reason as power delivery, because the system just consumes so many power. So today we are in 2019. So later I will show you the a video of our prototype of 48 volt tank. It's the capacity actually 100 kilowatts. The 60 kilowatts because the motherboard that we choose, Tiago Past, is a 600 watts system. And in this show, we also have a smaller tank. It's a sample. We have it in the booth, but the real tank is too big, so I'll show you a video. Oops, sorry. Let me show it. Oops. Sorry, something wrong with it. Oops. Okay, hold on. Sorry, let me see. Oops. Something wrong, sorry. Okay, sorry, some technical issue.
Wiwynn.
Okay. We took it from the lab. This is the Tiago Past. This is a top view. And use 48 volt power bus bar.
Wiwynn, your best choice for workload optimization and TCO.
Okay, so this is a summary of this tank. So it's the TOE is excellent 1.02, and this 48 volts transmission power, and we have a condensed system to reduce the evaporation, and also toolless design for ED service is and also there's a tank management system to serve this for easy maintenance of this system, and also we leverage the OCP Tiago Past motherboard. Okay, so we have 5 workshops that we share more our technology. The first is the management of the immersion tank. So to support the immersion cooling, not only the thermal, actually the management is very important. You cannot build and cannot manage it. So there's lots of efforts. The experience that we have is very different from our traditional management for immersion cooling. So our engineer, Xiaoyan, he will share the experience with us. And next is the 48 volt 2-stage. As I mentioned, that it improved the efficiency of all kinds of load. And the third is the immersion cooling. Our Lentis Pai, he's the leader of the product I just showed you. So welcome to his presentation. And the next is we have designed a EDSF JBuff. So Lentis and Mark A. Shao, he will share the experience of design the system. And next is the product I just showed. We have a 4U GPU server, and we separate into 2 fan rooms. So that's an innovative design to specifically optimize the thermal solution of a very high load GPU or accelerator system. And next, welcome to our booth. So all the products I mentioned is in the booth, and just mentioned that new technology. We have workshop. Welcome to our workshop and our booth. Thank you very much. Any questions? Okay, thank you.